Hi, let's start explaining this circuit. It's pretty simple. There is a coil here. This is like a relay, and with this relay, with how we control this coil, we can turn switch a load on and off based on when we require. So possible applications are one of them is the one I worked is a solar power management system where the solar panel where the solar panel will store the solar panel the solar panel will store charge to battery. Solar panel will store charge to battery, um, and based on the based on the charge left on the battery. So I have a what I call that appliances connected to this battery. Let's just say fans, and then I have light bulbs. Let's just extend this bulb. I have light bulbs. Yeah, I didn't get it right. So, according to charge. So I mean, sorry. This is how. Let me just. According to charge left in my battery, I'm gonna turn off some of the appliances as needed. So let's say I have this much charge. I'm sorry, what is happening here, bro? Sorry. Let's just say I have this much charge left, right? So according to how much charge left, we're gonna turn. We'll keep some of them on. Let's say we'll keep the fan on. We'll turn the fan should be actually green color. So how do I turn it off? Sorry. We'll keep some of the appliances on, and some will be off. So this is basically the demand side management system. And so let's see. So the idea is this particular small circuit is gonna help us. I mean, do the automatic turn on and off controlled by a microcontroller, right? So let's see what happens now. So basically, if I let's forget about things over here. Let's just say this is a straight line. So if I complete this circuit, what will happen is that current will rush. Now I'm gonna explain, and it might sound like I'm explaining to some really kindergarten kids, but just because I'm trying to learn myself, so interpretation of circuit diagrams. So if you don't like it, just turn it off, go to the beach and enjoy yourself. And I love you. I will still love you. Don't worry. So let's go again. So if let's say back to the circuit interpretation. If this circuit is complete, what's going to happen is that current will flow. Currents currents will always try to find the easy path. Okay, two things. First of all, currents will flow from high to low. So I have a path 5 voltage to ground. Okay, and I'm not gonna hide something. No crazy explanation. It's simple. There is 5 volts and there's ground, and current is gonna flow, right? And current will choose the easiest path. Now, when current will try to go through here, is gonna hit this. This is acting like a valve. This line, it's pretty self-explanatory. It should, from the diagram you should understand. It should actually no. From the diagram you can't understand. I knew it from beforehand. That this symbol means that current can't flow there. It stops the flow, this flow, and the what do you call it, from the top to bottom flow. So it stops it. So the other path current is left is that it's gonna go to here, and there's a coil, and it's going to come here and finally coming back to the ground. So what that means that anytime this circuit is complete, I'm getting this coil charged on, and when my coil is charged on, it will pull off. It will, at least in this circuit, we can see that it will pull off if this guy is one of those magnetic whatever it is. It will pull off this switch, and it will it will make this, it will open this circuit. So that was about that. So so this is the path. This is the path. It is gonna it's gonna go. It's gonna come down. It's gonna come down here, and the moment current tries to come back, it's gonna bounce back from here. So yeah. So the only path we have is this guy. Now the other path is that let's try to go other. Not sure about that. Yeah. So the other path we are left with is this guy. Now no, there's actually, it's not about other path. Let's talk about this path. Okay. So how does this go about? Now if I complete, let's forget about this. Let's say this is this is not there. If I let this circuit complete, what will happen is that my current will go from here, to here, to here. All right. So that's my current. So let's just say this is my current. All right. What that does is that it turns on my LED. All right. So you can understand that this LED, I mean this circuit, I mean this particular, let's just say, line, okay, is for my LED to turn on. In fact, what does this LED show is that you'll see that these two guys are actually from the same point. So when this circuit, especially I'm talking about, this circuit is on, this circuit is on at the same time. Okay. So just to show that this coil, if I just get a different color, make it more fancier, just to show that this coil is on, this coil is working. An indication, just like in programming we have serial monitor. Our serial monitor over here in electronic, I have seen my friend, some really cool, very talented friends who have been working on electronic boards, the way they would debug, and they would try to put a lot of LEDs, in everything, because you can debug it. Because imagine you, let's say the relay is not working. I mean, let's say this guy, or the same thing as this guy, the same thing. Let's say this guy is not opening it. So you'll be thinking maybe the circuit is not getting the right volt. I mean, we're not providing the right voltage, or something is happening. Maybe this guy is not working. So I mean, there could be so many possibilities. But if we have LED as an indicator, we could right away say, no, it is getting the current. Things are fine. There is something wrong with probably this coil, or something wrong with this guy. So so it makes debugging more easier. Okay. That the first foremost thing, that is this getting the is this getting the current? Is this getting the power? I mean, it's something. There is a signal. If the LED is on, that means there is a signal, right? So there are quite a few advantages of this LED. So yeah, and what is this resistor doing here? I mean, I asked a question when I was in second year. I had no idea about electronics. And why put a resistor? I mean, it makes it ugly. It makes the circuit more burdensome. I mean, let the current flow. Let there be no burden. I mean, obstacles. I mean, but if we actually take out the resistor, the current will overflow. The current will overflow the circuit, and this whole thing will burn. This whole thing. In fact, I think it will. The whole thing will be damaged. Now a final explanation is that how are we triggering the circuit? How I'm going to make this circuit complete? Just like the relay is able to close the circuit and open the circuit, this transistor can do pretty much similar job, except that it can be done through a microcontroller. Okay, in fact, you'll notice that even relay is done through microcontroller, except that a lot of behind the scenes are there. A transistor, let's if this, let's say this is the circuit, this line is circuit. Okay, I can control when I want to make this circuit close or open. Okay, based whenever I want. How I do that? I'm gonna just do that with this pin, with this. So if I provide voltage to this transistor at certain voltage, I don't know exactly how much, 0.7 volt. I don't know, I did it a long time back. It's not even that important. Just not that important. Okay, but a certain voltage, in fact, a microcontroller can provide with 5 voltage output. So I think whenever there is high, the high means max voltage, so transistor will close the circuit, so you have the circuit closed. And when you don't have any voltage at this point, at this end, when you don't have this voltage, by the way, this is coming from this output. It's gonna come from a microcontroller, right? So in our case, we were working with Atmega 324, 328p. I'm guessing. Like, how come I don't remember such an important thing? Because blame the Arduino. All we care is that we don't even look what's in the Arduino. Just put the things in the Arduino and code. That's how blind people are. I mean, how much blind can people be? So much blindness around. So there you are. There you are. I have a pin. I have an output coming from the microcontroller whenever I want, based on some conditions, based on some inputs and algorithms. I'm gonna turn this pin on. This pin is gonna go and I'm gonna push this, push this guy. And try to picture it like this. This is a straight line, and then there's this, somebody punched it. It just got a bent. Now when I push it from here, this straight line, this red line. Okay, actually the line is gonna be this red line, kind of gets pushed here, and this red line, eraser, where's eraser? There you go. It should be neat. It better be neat. Okay. I'll just do this. This red line. Straighten it. Get out of here. So, well, I'm thinking I'm going to just draw with a brush. It's a simple thing. So this red line get pushed from here to here, and it makes a normal circuit line. I think that's what the guys were thinking when they made the symbol. And hats off to you guys, whoever made that symbol. So, or hats off to me, who made that interpretation out of nothing. I think I deserve the hat off more than everybody. Back to the circuit. That's pretty much it. Nothing left. I thought that was pretty interesting. So there you go. Relay, pin, control, breakout. Just the word breakout is the correct word among the whole name. So thank you for watching.